setting up for the next one. Okay, so now we're going to do 10.5. Let me fix this so it's straight. So apply other angle relationships in circles. You know that the measure of an inscribed angle is half the measure of its intersected arc. This is true even if one side of the angle is tangent to the circle. So according to theorem 10.11, I'm going to adjust this a little bit. Oh, out of focus. There we go. I think that's better. No. Okay. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intersected arc. So for angle 1, which is right here, here we have this tangent and it hits right at this point, which is A. A little closer. So if we want to know what that angle is, whatever this arc is, if you take half of the arc, it's going to give us the angle. Same thing here with this big arc. So if we take arc BCA, which is the large blue one, and we divide it by 2, it'll give us what that inside angle is. That's what that theorem is telling us. Now we're going to do example 1. So it's telling us that line M is tangent to the circle. They want us to find the measure of the red angle or the arc. So I'm going to draw my circle. Draw my tangent line. My chord. A, B. Here's my circle. So it's telling us that the arc, which is a little blurry, oh, there we go, that's better, is 130 degrees. And then we want to know what angle 1 is. So to find what that angle is, so the measure, let's go over here, zoom out a little bit. We want to find the measure of angle 1. So since we know that this arc is 130, 130 divided by 2, let's go through the math, 2 goes into 13, 6 times 12, 2 goes into 10, 5. I know Drew knows it in his head already. So the measure of angle 1 is 65 degrees. That's for part A. Now for part B, we have a different circle. Oops. So I'm going to draw my next circle. So we have this circle, we have this tangent line, M, it meets at point L. We have this chord, K, and then we have the large point J. And then it's telling us that this inside angle is 125, and they want us to find this large arc length, which is right here. So they want us to find that arc. Well, according to our theorem, whatever this arc length is, this angle is exactly half. So if we do it conversely, the opposite way, that means to find the arc length, we would take that degrees and multiply it by 2. 10, 5, 2. So arc KJL is equal to 250 degrees. Now we're moving on to the next section. Intersecting lines and circles. So make sure that you copy these 3 different scenarios into your notes. There we go. So if 2 lines intersect a circle, there are 3 places where the lines can intersect. So it can either lie right on the circle itself, inside the circle, or outside the circle. So here's our next theorem. Theorem 1012, angles inside the circle theorem. If 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angles. So if it's intercepted inside and we want to know what angle 1 is, well, you would take this arc length plus this arc length and then divide by 2, and it's going to give you the measure of angle 1. For angle 2, which is the larger ones, the same thing. You're going to take this arc length plus this arc length and then divide by 2. That's when it's on the inside. When with the other scenarios, when it's on the outside, depending on how the angle is either inscribed in going through the circle or tangent to both sides or inscribed with both, we have the different formulas for those. Let me get a little bit more clear. There we go. So if a tangent and a secant, 2 tangents or 2 secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So if we have this secant with the tangent, then you would take the larger arc minus the smaller, then divide by 2, and it'll give you that angle. If the angle is tangent on both sides, it's the larger one minus the smaller one divided by 2, so same thing. And then for this one, the larger arc minus the smaller arc and divide by 2. So for all 3 scenarios, you're going to be doing the same thing. It's always going to be the larger arc minus the smaller arc, divide by 2, and it'll give you that angle. So for example 2, wants us to find the value of x. So I'm going to draw my circle. So for this scenario, it is inside so we're looking for this x degrees. This is 156, and this is 130. So they want us to find this x degrees, and here's our picture. Well, there we go. So according to our theorem up here, when it's inside like this, we're going to take these 2 measures, so this arc length, whoops, and this arc length, add them up, and then divide by 2, and it'll give us the x value. So 156 plus 130, get 6. 286, then divide by 2 over here. 1 4, and then 3, which terminates. And so we get this x value to be 143 degrees. And that was because it was inside, like this scenario. Now we're going to do the other ones. The other scenario when it's not just right inside. So now we're going to look at this example. Has some stuff on it. So it wants us to find that value of x. So I'm going to draw my circle with one tangent side and one secant side. See, not so clear. There we go. C, D, B, A. So we're looking for this angle, which is x. This is 76, and this is 178. So for this type of scenario, you have this arc length, and you have this arc length. So according to our theorem, we would take the large one, subtract it from the smaller one, and then divide by 2, and it'll give us our x value. So 178 minus 76, this is 2, 10, and now we're going to take that value and divide by 2. It's 5, 1. So this value x comes out to be 51 degrees. It's one of those real world problems. I recommend that you go onto the myhrw.com and look at it. And that was 10.5. Bye, guys.